Hello students, following question is from part test 2, subject signals and system, chapter Z transform, and the question is asked for 1 mark. Question is, a discrete signal y of n is related to another discrete signal x of n as follows. Y of n is equal to x of n by 2 when n is even. For odd values of n, y of n holds the value of earlier samples. Fine. And we need to express the z transform of y of n in terms of z transform of x of n. The options given are, option A is x of z square, B x of z square plus 1 over 2 in common, z plus 1 over z times x of root z if x of 0 is 0. Option C is 1 plus z inverse whole into x of z square. And option D is x of z square plus 1 over 4 times z plus 1 over z whole into x of root z plus x of minus root z if x of 0 is 0. So it is given that y of 0, so let us consider n as 0, which is an even number. So y of 0 will be equal to x of 0 by 2, that is nothing but x of 0. And now let us consider one odd number, that is 1, n equal to 1. So I will get y of 1 is equal to y of 1 minus 1, that is a previous value. So we get y of 0. So y of 0 was nothing but x of 0. So we have y of 1 is equal to x of 0. Fine. So in this case we will use unilateral z transform. Okay. So the formula is y of z is equal to summation n equal to 0 to infinity y of n times z raised to minus n. Fine. So which is equal to y of 0 z raised to minus 0 plus y of 1 z raised to minus 1 plus y of 2 z raised to minus 2 and so on. So now what I will do in the next step is replace the odd numbers of n in y with the corresponding values. So over here see, it was y of 1, so y of 1 is replaced by y of 0, the previous sample. Y of 0 is retained over here since n over here is an even number. Similarly y of 2 is also retained. However, y of 3 is changed to y of 2, the previous sample. Again, y of 4 is written and y of 5 is changed to y of 4, the previous sample. Fine. Rest all things is same. In next step what we do is replace y with the corresponding x terms. So as seen over here, so y of 0 was x of 0, and in a similar way we will replace it. So y of 0 got converted to x of 0 in this both values. And now y of 2 would be converted to x of 1, that is x of 2 by 2. Fine. Similarly here also we will get x of 1, and finally here we will get x of 2. Fine. In the same manner. Now what I will do is take the above part common, and in the second part, like I will segregate it in such a way that I get this form, x of 0 times z raised to minus 0 plus x of 1 times z raised to minus 2 plus x of 2 z raised to minus 4 plus so on, plus z inverse. I will take z inverse common from this part, from the odd powers of z, and I will form again the same thing as seen over here. Fine. So these both are identical. So next what we will do is represent the z terms in terms of z square raised to some power. So what we get, the equation as x of 0 z square raised to minus 0 plus x of 1 z square raised to minus 1 plus x of 2 z square raised to minus 2 plus dot dot dot, and plus z inverse again x of 0 z square raised to minus 0 plus x of 1 z square raised to minus 1 plus x of 2 z square raised to minus 2 plus dot dot dot. Now if we carefully look onto this equation, this part of the equation, we would see that it is nothing but x, capital X of z square. Fine. Plus this z inverse is retained, and again this part is nothing but x of z square. Fine. So if we take x of z square common, what we get is 1 plus z inverse x of z. That is nothing but our option C. Fine. So whenever we are given such kind of problems, we would start with simple unilateral z transform, and step by step we will represent or replace the z terms with the corresponding terms, and finally arrive to a equation, the final answer, which in our case is 1 plus z inverse x of z square. That is nothing but our option C. Thank you.